In this video, we are going to learn the concept of the root mean square voltage for a sinusoidal waveform, something like this. So, this is a sinusoidal waveform that varies with time t, and at t equal to 0 it's 0. At let's say time t is at this is actually, let's call it theta, so we can present it the matter in a mathematical form, and this is the peak voltage. We call it, let's say, vmax, and this sinusoidal waveform can be represented as v is equal to vmax sine theta. The concept of root mean square comes from the fact that, let's say, we have a resistor in a circuit, and that circuit is driven by a sinusoidal waveform, which is varying something like this, and we want to find out the power in this resistor. Then this power will be equal to V square divided by R. So if we want to find out what is the average power during one cycle of this sinusoidal, as theta varies from 0 to 2 pi, then we cannot just simply take the average of this voltage, because if we take the average of this voltage V from 0 to 2 pi, the positive cycle will just take the negative cycle. But if we take the square of this voltage, then this positive cycle and is positive, and then the negative cycle also becomes positive, and we get an average of this, and then we take the mean of this square, and then we take the square root. So essentially what we are required to find out is, let us say in this we replace this sinusoidal with a simple DC, then what is the value of that DC voltage which will produce the same power averaged over a period of time that will be equal to this sinusoidal. So that is the physical significance of finding the root mean square speed. So we will derive this formula, and to derive this formula we first need to take the square of this. So if we take a square, V square becomes Vmax square sine square theta. And how do we find the average of this? So V square, I will call it average, will be equal to, we take it. So how do we find the average of any number? We take the value here, and we measure it here, we measure it here, we measure it here, and then we take the average of these things. But in case of a continuously varying function, the average becomes Vmax square sine square theta multiplied by d theta. So we multiply it with this small segments, and then we take the integral of these things, as theta varies from 0 to 2 pi, and then we divide it with this whole time period, this d theta thing. So that will give us the average value of the square of this waveform. So mathematically we can represent it as Vmax stays constant, so Vmax square divided by 2 pi and integral of sine square theta d theta, as theta varies from 0 to 2 pi. Now cos 2 theta is equal to 1 minus 2 sine square theta. So we can write sine square theta as 1 minus cos 2 theta by 2. So this becomes Vmax square divided by 2 pi integral 1 minus cos 2 theta divided by 2, as theta varies from 0 to 2 pi d theta. 2 comes outside, so we have Vmax square divided by 4 pi integral of 1 minus cos 2 theta d theta 0 to 2 pi, and this becomes vmax square 4 pi, theta integrated becomes theta, cos 2 theta is sine 2 theta divided by 2, theta is from 0 to 2 pi. You can simplify it as vmax square divided by 4 pi. When theta is 2 pi, this is 2 pi minus sine into 2 into 2 pi, sine 4 pi is 0, minus, then theta is 0, this is 0, plus, when sine 2 into 0, sine 0 is 0. So this whole thing goes away, only 2 pi is left. So we get vmax square divided by 4 pi and 2 pi. So 2 pi cancels out, we are left with vmax square. So v square, the average of v square is vmax square divided by 2. So if we say vrms is the root of the mean square. RMS, root of the mean square. We got the mean square, and if you want to root, this is the square root of this whole thing, vmax square divided by 2, and this becomes vmax divided by square root of 2. So this is the formula that we use to find out the relationship between the max and the RMS velocity. If we are given, let's say, instead of the max voltage, we are given V peak to peak. Let us say we are given this is V peak to peak. Then the peak to peak will be twice the V max. So we can also represent it as V RMS. V peak to peak is equal to 2 times of V max, or V max is half of the, this is V max is half of the VPP. So you can write it as VPP divided by 2 square root of 2. So these are some of the concepts that are used to find the heating effect of a voltage in a resistor, and that's why we find the Vrms and V peak to peak.